Hello everyone. In this application example number 6, we are asked to analyze this process. From a heat integration point of view, this means that we want to know how much this is using in utilities currently and how is the minimum use of utilities. This minimum consumption is different for every minimum temperature approach. This is not set, then we're gonna look for the current minimum approach and use it. For the data extraction, we have one hot string from 180 to 80. This is the outlet of reactor number 2, 180 to 80, taking out 2000 kilowatts. A second hot stream from 130 to 40, these are the bottoms of the distillation column, and take 2400 kilowatts plus 1200 kilowatts of cooling. This is the second one, 130 to 40, with this duty. A first cold one from 30 to 120, this is the feed, and it takes 2000 plus 1240 kilowatts to heat. And one other cold stream from 60 to 100 Celsius, taking 2400 plus 800 kilowatts. We have not detailed knowledge on the streams, then we must take all of them as linear. Concerning the current utility consumption, we have two heaters, 800 and 1240 kilowatts, know nothing about the reboiler. This means 2040 kilowatts. And for cooling, we have just the final bottoms cooler, 1200 kilowatts. Then this is the only cooler. Concerning the current minimum temperature approach, we have just two process heat exchanger. We don't know nothing about the temperature of heaters and coolers about these utilities. So, calculating the temperatures of the process heat exchanger, we can check that this is in this second heat exchanger where the minimum approach occurs between 70 and 60 Celsius. This is in the cold side of the process heat exchanger between the bottoms and the heads, the recycle. Knowing then the problem table and the minimum approach, we can build the composite curve diagram. Here you can see it with stream number 1 extending till 80 Celsius, stream number 2 coming from 130 to 40 Celsius and compounding with stream number 1. This is for the hot composite. And a similar thing for the cold composite with stream number 4 extending all along and compounding in the middle with the stream number 3. Placing it at 10 Celsius, the minimum approach, this is the pinch, we can calculate the minimum cooling and the minimum heating. Minimum cooling is 120 kilowatts and minimum heating is 960. These give us an excess utility consumption of 1080 kilowatts for both heating and cooling. This means around 50% half heating and almost the complete cooling. And here, in order to introduce utility design using the composite curve diagram, you can see an example of heating and cooling. The minimum heating 960 at the minimum temperature 84 to 84. This is a flat stream. And the minimum cooling 120 kilowatts from 30 to 60 Celsius. That is not very normal. We will see utility design in much more detail. And this is all.